Welcome everyone, and thank you for attending this evening's webinar. My name is Brad Kilstrashone and I'm the Sustainability Officer at South Gippsland Shire. I'll be your MC for tonight's webinar. I'll start tonight by acknowledging the Bunurong and the Gunai-Kurnai peoples as the traditional owners and custodians of the lands and waters that I and many of you in South Gippsland and Bass Coast live and work on. I pay respects to their elders, past, present, and Aboriginal elders of other communities who may be joining us tonight. If you're joining us from elsewhere in Victoria, I invite you to introduce yourself and acknowledge the country you're joining us from in the chat if you wish. Tonight's webinar, Sustainable Building Materials, is part of a series of webinars that Bass Coast Shire and South Gippsland Shire Councils have partnered with Renew in across 2024. Renew has been working in the sustainability space for over 40 years as an independent, not-for-profit body with a mission to inspire, enable and advocate for people to live sustainably in their homes and their communities. This webinar and all webinars will be recorded and made available on the CAP website, the Community Action Portal, for future viewing. And there's a number of webinars already up there ready for you to go and review if you wish. The first 6 webinars in our Sustainable Living series covering the topics of solar, home batteries, all electric homes, electric vehicles and winter comfort are now available to watch if you missed the live event. We'll put a link in the chat. The 2024 Sustainable Living series is designed to equip you with information and knowledge to make your homes more comfortable, more energy efficient to live in and cheaper to run, and more environmentally friendly. So without further delay, I'd like to welcome our expert presenter for tonight, Dr. Martin Freeney. Dr. Martin Freeney is a designer, educator and researcher in the field of sustainable design and architecture. His company, Earthship Eco Homes, is a consultancy that develops housing solutions that minimise environmental impacts and maximise resilience to climate change. He has a PhD from the University of Adelaide School of Architecture and the Built Environment, a Bachelor of Industrial Design, Diploma of Building Design, Certificate for in Building and Construction, and a Certificate of Permaculture Design, all of which he brings to bear upon the problem of how to create ecological housing. He is a teaching and research academic at the University of South Australia and a member of the Building Designers Association of Australia. Welcome, and over to you, Martin.
Thank you very much, Brad. It's a pleasure to be here. Just one correction there, my bad. I'm an ex-academic. I ended a 20-year career at the university just recently, and now I'm just 100% on designing sustainable homes. So without further ado, I'll start my screen share. So yes, my talk is about sustainable building materials. And I won't read through all of this, but I'm going to start off with a case study of an eco home. I'm going to talk a little bit about design. It's almost impossible to talk about materials without talking about design. I'll try and keep the focus on materials, looking at like key issues regarding materials, and also look at some of the main construction elements of a home: the floor, the walls, roof, insulation, and windows and glazing, and look at some of the material and product options there. So I'll start though just with a little bit of kind of history, and also going to Brad's acknowledgement of the first Australians. Here's a couple of images that show the kinds of shelters that Indigenous people made in Australia, and I think there's a lot of really good things that we can learn from this kind of thinking about, using materials that are at hand, and using materials that don't cause sort of waste and pollution at the end of their life. So let me start by talking a little bit about design. What will we build and how will we build it? So it all starts, of course, with the design team, which is generally you, the homeowner, working with designers or architects. Also engineers often get involved. These are all the people who are making really important decisions about design, and as part of that is, of course, the materials that are used to bring the design to life. And we're also working towards, complying with the, or not working towards, we are going to comply with the National Construction Code. But I want to just sort of point out that the construction code sets a minimum standard. And so I'm always trying to exceed the minimum standard where possible, with budget and other constraints like that. So at this design stage, materials and costs are locked in. And so this is just such a critical stage. It really, of course, sets the tone for the whole project. And over the life of that home, that is going to be a really big deal, whether it's a comfortable home to live in or not. And running costs and all that kind of thing are going to be baked in at that design stage. So one of the main considerations I want everyone to consider is the size of their home. Of course, this determines how much or how many materials are needed and have to be paid for by the owner, assembled by the builder, and then, of course, maintained by the owner. So if you can build small, that is a good thing. And we've got the two extremes there, the mansion and the tiny house. And perhaps not surprisingly, Australians actually build the largest homes in the world. And the problem with that is that big houses need more energy to heat and cool. And as I've also just explained, they need more materials. And so that has a greater impact on the environment and your hip pocket. So I'd like to now look at a case study of a home that was it's completed a couple of years ago now. All the work I do is inspired by the Earthship concept, which the idea of that is that it's trying to be super sustainable. It uses passive solar design and self-sufficient off-grid systems to make the building autonomous or self-sufficient. The idea there being that you don't have utility bills, and also it's minimizing the impact on the environment. So what I'm about to show you is of a modest size. It's about 130 meters squared, 2-bedroom, 1 bath on a suburban block of land, reasonably good size, 900 square meters, and it cost about $400,000, which included, batteries, panels, rainwater tanks, grey water system, and it was built by an owner builder. So it's called Earthship Gulwa. This is the computer rendering of it. Here is the floor plan. One of the really interesting ideas of Earthship homes is that they have a greenhouse on the north side, or sunroom. Basically, we try to face all the windows, the double glazed windows, to the north, where that makes the most sense, because that's where you get the best bang for your buck in terms of getting energy into the home in the winter, and also helps you block the summer sun by having those windows to the north. I'm not going to talk too much about that. Try and stay focused on materials. Straw bale walls shown here in yellow. So I'll be showing you some photos of these in a minute. The tyre wall is back here. Yes, we build out of old car tyres, filled with earth. And then at the back, there's what's known as the earth berm, which is thousands of tons of earth, which helps to insulate the building. And then there are earth tubes, which are underground ventilation pipes that bring fresh air in. It's sort of a bit like a free air conditioning system that has no moving parts. So here's a cross section of that building. There you can see the earth tube and the greenhouse or sunroom, which starts to get warm, and the hot air rises up out of open windows that are high in this front face of the building. That draws warm air in, which gets cooled down as it moves through that earth tube and into the living room. So we call that a convection current, or it's sort of like a a thermosiphon kind of thing where hot air rises and pulls the air in without needing fans or anything. The other interesting thing about having a sunroom on the north side of the building is it creates a buffer zone. So that isolates the living spaces from extreme outdoor temperatures. And then the earth berm is also a buffer zone. The highly insulated roof is a buffer zone. So you can see that those living spaces are really isolated from what's going on outside. So that's the concept. This is a shot taken with my smartphone using an app called Sunseeker. Shows you the path of the sun. So this is also a really useful design tool. I think when you're starting to think about a block of land, you can start to evaluate where the sun is and whether it's going to be blocked by other buildings or trees. And so, yeah, this is one of the things that your designer will do is like look at where the summer equinox and winter solstice sun will come into the building. And of course, that all works a lot better if the building's facing north. And another technique used by designers and architects is doing these shade studies, showing different times of the day. This is in the summer, in the winter, and in the equinox. And what you'll notice here, if I go back to winter, is how the sun really penetrates deeply in to warm the building for free, whereas in the summer it does not. So here is the tire wall under construction. So yeah, this is a load-bearing wall, which means it sort of offsets a whole lot of regular materials like steel and timber that would otherwise need to be manufactured to build a wall, a load-bearing wall. Here inside the building, you can see this is, a few months later, the tire wall and a straw bale wall on the right, and then just a regular wall on the left that will be have plasterboard fixed to it. And there's that same room again with the plasterboard and the earth render going on the tire wall and the rendered straw bale wall. And another room in the home tire wall there, all rendered over. And the great news with this building is that the fire has not been needed because it just maintains a nice temperature through some of those design techniques I've explained. The other thing we do with earthships is we upcycle bottles into colourful bricks, which you'll see in that photo as well. So yeah, there's some YouTube clips if you want to do more research on that. There's another earthship project in Victoria. I just thought I'd throw in floor plan and photo of it under construction, because this is in Victoria, where you're listening from tonight. All right, so moving on from the case study, I just want to sort of share a few little retrofit ideas before I do a bit of a dive into all these material properties and what makes a material ecological or sustainable. So I guess the first thing to note there is that upgrading a poorly performing home can be a very sustainable thing to do rather than knocking it over and starting again. And some of the things that you might like to try, some of the low-hanging fruit, which is, the easy things to do, is things like draft sealing, as you can see in this photo. For probably under $100, you can dramatically improve the thermal efficiency of your home just by stopping the drafts. Adding ceiling insulation is another obvious one. Double glazing, or there's a product called magnetite, which is where another pane of glass or perspex magnets onto a frame to turn a single glazed window into a double glazed window. Ceiling fans are a great idea, and things like solar panels are also a really good idea, especially when they're used to power air conditioning. And the note there is about thermal mass. I'm going to explain to you all about thermal mass in a minute, but that's going to work best if you can turn on your air conditioner during the day and cool off some thermal mass in your home so that you don't need to run the aircon at night. And so a more substantial upgrade might be an extension to the house. So a greenhouse, sunroom, or atrium, as I've just sort of shown you with that Earthship example. I think they're a fantastic idea. Just sort of capturing that free energy from the sun, and then perhaps using some ducts and low wattage fans to blow warm winter air into existing rooms. So here's a few examples of some beautiful sunrooms. This again is one of my designs from the Narara Eco Village in New South Wales. That greenhouse on the north side, also sort of providing some other functions like laundry and garden area. Another thing I think is worth just mentioning really quickly is some sustainable products. We're sort of in this grey area of products and materials. I'm going to talk a lot about windows later, which arguably are a product, but I just thought quickly mention that composting toilets I feel are really an excellent sustainable choice. Solar hot water services or heat pump hot water services are going to save you a lot of money and electricity or gas. So they're good for the environment and your hip pocket. Solar panels and batteries, same. They save the environment and your hip pocket, and also grey water systems are going to help you save water. And the tip here is that if you can think about this at the design stage and not do them as add-ons and integrate them into the design, that's gonna work better. So just a couple of photos of some composting toilets. There's basically two main types. There's one that goes under the floor on the left, and then the one on the right is much easier to retrofit in because it just sits on the floor. You don't need an underfloor space. So as I said, it saves you a lot of water. It also makes compost for the garden. And the downside is the maintenance and the cost of these things. But I'm a huge advocate of these. I have one myself and I love it. My kids love it. So yeah, I think they're great. Yeah, the hot water service on the left, we've got one of the most efficient types. There's a few types available, but one of the most efficient. It's an Australian invention, these evacuated tubes. Here you see one which doesn't have the tank. The tank is at ground level. And here we've got the close coupled one with the tank. So these are terrific. The downsides is that, if there's not enough sun or you empty the tank, you're going to need a backup system like gas or electricity, which is often just, often there'll be a electric heating element in one of these tanks. So that's okay. Or the other, really energy efficient option is the heat pump. So they come in a split system or a combined unit, and these are very popular these days and saving people a lot of money and reducing pollution. All right, so on to sustainable material properties. What makes a material sustainable? So when you're choosing materials, there's quite a few things that need to be on your mind. So energy issues, I've sort of been talking about this a bit already. We talk about embodied energy, which is the energy used to make the material, and also the operational energy, which is the heating and cooling energy of the home. And that all sort of stems from these material choices. So insulative value, for example, is important. I'll go into that in some more detail in a minute. So yeah, the sustainability, environmental impact or ecological footprint is kind of closely related to that first one. The durability, longevity, resilience against things like bushfires, extreme weather, termites, condensation and mold, of course, that's important too. Aesthetics and beauty, which is of course subjective, and you've got to ask yourself, what do you find beautiful to look at? Cost, maintenance, and also availability are all factors. And what are we trying to do here? We're trying to reduce the eco impacts of manufacture, make the home more energy efficient. We're trying to make sure that the people building your home are not going to be poisoned. And likewise, when you're living in the home, there's not going to be toxic off-gassing. It's got to be not too expensive and not require a lot of maintenance. And also not cause problems during demolition. And this is one that often kind of gets overlooked. People aren't able to think that far ahead. So let's look at thermal performance. This is the heating and cooling energy. And it's a big deal. It's going to be the biggest cost of the running of your home is how much it costs to heat and cool it. And it's possible to get this like right down to pretty much zero with good design. So insulation and thermal mass are the two sort of types of materials that designers use to try and keep that heating and cooling energy down and just naturally create this beautiful indoor temperature. And so what you see on the right here is a screenshot from yourhome.gov.au. There's a link there. Just Google your home and this should come up. And there is a heading, passive design. And it talks about design for climate. And lots of good advice in here about how to actually design for your climate. What's the right amount of insulation and thermal mass? So for example, in the tropics, you're probably not going to want a lot of thermal mass because that just holds onto the heat and keeps it warm overnight when you don't want it to be. Lots of ventilation is the key in the tropics. Whereas in temperate climates, thermal mass that's well insulated plus passive solar design is going to lead to a very energy efficient home. So let's talk about insulation. Insulation slows down the flow of heat energy. Keep in mind that heat flows from hot places to cold places, and it's measured with R value and U value. All right, so a couple of examples here of insulative materials. On top, we've got these days it's made out of recycled glass, quite a high content. I think about 30% recycled glass is used to make those insulation bats that are commonly available at hardware stores. And then the perhaps more ecological, or not perhaps, I think definitely more ecological option there is a straw bale. Straw bales are waste products from making our food. So instead of burning this stuff, we can actually turn it into houses, really well insulated houses. So there's lots of types of insulation. We've got the bat insulation we were just looking at, which comes in bats or rolls. That's a blanket, typically used for roofs. Sometimes it's got the shiny foil on one side. Rigid insulation, polystyrene, often used in under a floor. Block insulation. So you've already talked about the straw bales, but there you also see some hempcrete blocks. And then there's spray foam insulation and recycled paper pulp, which I think is also an excellent sustainable choice because we're using recycled paper. So R values. This table here shows various different insulative products and different thicknesses of those products, and then the resulting R value. And so one thing to notice that where we've got double the thickness, 50 mil versus 25 mil. Whoops. If we just pick one of these, this first one, 0.71, if you double that, you get 1.42. So double the thickness gives you double the R value. And then also another important thing to understand is if you do 1 divided by the R value, you'll get the U value, and vice versa. So it's just the inverse of each other. Another thing to keep in mind when you're hunting around on the internet is that the units used in America is about 5.7 times larger. So it gets quite confusing when you're looking at American websites. Another really important thing about insulation is how it gets installed. It's really important that, I mean, this applies more so to those bats. So no gaps is really important, and also not crushing it, because if that insulation bat is crushed, there's not as much air in it, and it's the trapped air that is, helping stop that heat flow move as quickly. So that could be an advantage of things like the blown in recycled paper, cellulose, or the spray foam. Although I don't love the spray foam because of the toxic chemicals. So again, I refer you back to your home where you can find some key points about insulation. Now I want to talk about thermal mass. Thermal mass acts like a battery to absorb, store, and release heat, usually at night time when the sun's gone down and you want some extra heat. And it helps to regulate indoor temperature by what they call a thermal flywheel effect. So here is an actual flywheel that stores rotational energy. Here it's a big wheel that once you get going, it just wants to keep spinning, and here it's being used to drive an ancient lathe for wood turning. So it's a similar kind of concept, this sort of, we call it a thermal flywheel, which stores heat energy. And so this concrete slab in this example stores the energy from the sun during the daytime, and then at nighttime, that heat gets released and helps improve the indoor temperature without, active heating. So there's all sorts of types of thermal mass. Concrete is probably the one we're most familiar with, but fired clay bricks are thermal mass, mud bricks, rammed earth, and even water is thermal mass. It's dense materials, whereas insulation is like light, fluffy, airy materials. And this is a photo of the building I'm standing in right now. This is my earthship project. And here you can see a floor made out of earth, which is soaking up the sun and storing that energy until nighttime. And again, back to the Your Home website, there's lots of good information about thermal mass there as well. And so what works really well is insulated thermal mass in a temperate climate. This cross-section here shows a reverse brick veneer wall, which is where instead of putting the bricks on the outside of the building, we pop them on the inside. And so now we've got insulation to the outside, which is stopping that heat flow through the bricks and into the outside air. So just by swapping those two materials around, we get dramatically different results for heating and cooling energy. And this is a really kind of obvious and simple way using commonly available materials to improve the performance of a home. So let me move on now to eco impacts of materials and how to reduce your eco footprint throughout the whole life cycle from manufacture to end of life. So it's really important to think about this idea of a life cycle of a home. So as I said before, we've kind of figured out how to make buildings more energy efficient, and that reduces the operational energy, the heating and cooling energy. The next big challenge for all the designers out there and for you is to figure out how do we reduce the embodied energy of the construction materials and improve end-of-life outcomes, hopefully recycling instead of demolishing things and sending it all off to the landfill. And this is known as a circular economy. This idea of upcycling materials in continuous loops. So instead of sending things to the dump, they get used again and again. And that leads into this idea of life cycle thinking. And so I've listed sort of the four main stages there of like raw materials, getting turned into building products through a manufacturing process, then getting used, during the occupancy stage of the building. And then ultimately, every building is going to get knocked over one day. So we need to think about that as well. So here's a little diagram that shows those 4 stages. And those first 2 are characterized by a lot of embodied energy. The use phase, it's all about reducing the operational energy. And then in that final stage, there's also embodied energy with carting all this stuff off to the dump or processing it. And the circular economy is where it all just goes around nicely in a circle, and we're not having to do as much mining or forestry to get the materials we need to build our homes. And yes, there's also transport energy. You can see a little truck whizzing around, lots and lots of energy moving materials around. So number 1, what can we do to reduce the eco impacts? Basically, we have there can be a lot of waste in our construction practices. So that's one thing. Sorry, I'll give you some. I'm going to go through a case study which explains this in some detail. 2, I'll just give you a quick overview here. Basically, this is running costs: electricity, gas, water, sewage, and maintenance. 3, end of life. Yeah, this is not a good result here, just knocking things down and making a whole bunch of rubble. So let's look at a case study of the life cycle of timber. And I want you to sort of, just maybe after this presentation, think about some other material and see if you think you can imagine how all these things are made. But, obviously, I suppose with timber, it starts with a tree. And we kind of need all these things to get the tree to grow. And then we have to harvest the tree. And it can be a real challenge to actually find sustainable timber that is, harvested in a way that's not just clear felling forests, especially our old growth forests. So look for this Forestry Stewardship Council logo, and that's a good indication that some more sustainable practices are being used rather than clear felling old growth forests. Because of course, this kind of thing is the result of unsustainable practices, and this causes all these other cascading effects like less rainfall, loss of beauty, erosion, etc. That first one there, habitat loss. There's also social concerns. People aren't happy about forests being decimated. And here we got the transport of the raw material, lots of carbon emissions, moving around big, heavy lumps of timber. Then it has to actually be processed, turned into some sort of usable material. It's got to be kiln dried, which is super energy intensive. Perhaps a more ecological way is just using air, but then the downside there would be it takes longer. And another ecological idea that, again, maybe speeds things up a little bit, but not as fast as the kiln drying and not as readily available. There's also even energy used while it's just sitting in the warehouse. And of course, the materials, the transport emissions to get it to your site. Although if you look carefully, this is a 100% electric truck, so help is on the way. And then here we've got timber waste during construction. And you also got to think about what maintenance you're going to have to do on that product. What sort of, in this case, what are the chemicals that are going into making this stain or varnish? And at the building's end of life, what happens to all that timber? Is it going to get put in the landfill, or where it could potentially create methane emissions, which is terrible for global warming, and incineration is not much better. So perhaps a better way is, can we design timber buildings? Here you see a beautiful timber building that is actually designed for disassembly and reuse in another building. So this is kind of the future. So in summary, throughout the life cycle of timber-based materials, there are lots of opportunities where we can make better outcomes. And it's by considering all these life cycle stages, looking for FSC certified products, avoiding waste on site, specifying eco-finishing and maintenance products, and designing for disassembly. This can all lead to much better outcomes when we're talking about timber. And so, of course, I don't have time tonight to go through a whole lot of other life cycles of other materials, but your homework is to just, put your thinking cap on and think, well, how is something produced, and what might happen to it at end of life? All right, so another key concept that I've mentioned already is embodied energy, the energy used to manufacture something. And this ties in closely with carbon emissions. And so here you see a list of materials on the right. Aluminium is right at the top of the list, 358 megajoules per kilogram. And I want you to take a look at concrete, which is only 1.1 per kilogram. Now, don't be fooled here. I've done a little bit of maths here to sort of show that for your typical floor, or perhaps not typical, this is a large floor slab of 250 square meters, 100 mil thick. Basically, it's 6 tons of concrete. So when we multiply that by the 1.1, we come up with a very large number compared to, if you think about how much aluminium might be in your window frames, for example, it's probably only 20, 30 kilograms compared to 60 tons. So looking at this list can be a bit deceptive. And so that's where life cycle assessment comes in. This is a sort of scientific way, often uses some software. This one's called Circlos, that kind of adds up what all those masses of materials, what those carbon emissions are, and sort of comes up with a number for how much embodied carbon there is inside a particular house design, or it's a particular material or product. And so this now gets used for certifying products. You can see here at the heart of the Global Green Tag rating system, LCA, life cycle assessment, is used to evaluate how green a product or material is. And you can do a search. I did a search here for insulation, and it can provide some examples of products that have gone through this life cycle assessment system and been shown to be more green than comparable products. So there's a few certification labels. Recycling waste, creating a circular economy. In this slide, you can see how steel, about 93% of it's recycled, compared to something like timber, where only 13% gets recycled, and a lot goes to the landfill. And concrete, a lot of it gets downcycled, perhaps into things like road construction materials. So,
Martin,
yeah.
G'day, Martin. I've got a couple of questions, if you don't mind. Maybe I'll just throw a few in now, if that's okay. The first question is, are all double glazed windows still imported? And if so, from which countries? And are they transported by air? Do you know much about double glazed? I'm guessing that means the glazing units, because I know that people make double glazed windows locally, the actual window frames and things, but are the double glazed units that go into those windows imported? Do you know?
I'm pretty sure we have a local manufacturer. Viridian, I believe, is an Australian manufacturer. They get made locally. But yeah, I'm sorry, I'm not 100% sure. I have got some slides coming up on double glazing.
Great. Thank
Any
you.
other questions?
Yeah, one more. Is there any progress with testing of houses for energy efficiency before completion certificate? So I guess the basis of that is a lot of the energy rating of homes is sort of as built, but not actually testing the houses. There's no physical tests done.
Yeah, so let me just understand the question. Is the question asking about, yeah, like once it's been built, how you test it?
Yeah, I'm guessing the question is, yeah, that's how I'm reading it. So I think one of the arguments that you hear is that you can build your house up to a current standard, say 7-star as required, but then how does it actually perform? Because nobody comes along and actually tests the house, like doesn't do a air pressure, air tightness testing or anything like that. So I guess that's the basis of it. Yeah.
Yeah, I think it's a great question, and I would love to see more testing of as-built homes, because yeah, at the moment the system we have in place is that you have to get your energy assessment done at the design stage to show that the house is predicted to meet the minimum 6 or 7-star minimum rating. But that's a prediction that's using some software and a lot of assumptions.
Yeah.
Especially about, another real confounding factor here is how one family might use the home versus another family. Like one family might be really good at using the house in the right way, opening and closing windows and turning off lights and heaters and all that kind of stuff, whereas the other family might be terrible at that. So there's all sorts of problems here that are kind of somewhat hard to solve. But yeah, I'd love to see a lot more going back and testing. You mentioned the air leakage blower door tests. That's increasingly common. During the construction stage, they'll do the blower door test to make sure that the building's been sealed adequately. So things like that are steps in the right direction, but very few. I kind of feel it's on the designers and architects of this world, but maybe the homeowners, just to sort of demand that this monitoring, and this was a huge part of my PhD, was like putting sensors in homes to actually see how they perform. That to me, that's absolutely fascinating. I've got an app on my phone. I can monitor the performance of this earthship building I'm in now. It's just every half an hour it takes another reading and makes all these beautiful graphs, and you can sort of start to understand how energy efficient a building is. So yeah, let's have more of that in the future, but it's not mandatory at this stage.
Fantastic. Thank you.
Great questions. So salvaging materials can be a good idea. It can also be it can make design and engineering a bit tricky, because now the designer has to actually work with a whole lot of given dimensions rather than just being able to specify whatever suits. So my tip here is like maybe go for things like the sinks and toilets and fixtures that aren't quite so critical, yeah, that might just be a little bit easier. Also easy to store, whereas huge piles of timber or something with nails in them and all that kind of stuff, like there can be a whole lot of extra complexity to working with recycled salvage materials. So toxicity and safety. This is a blast from the past, but I'm just sort of putting it out there that, we kind of got to always be aware of this toxicity issue. The latest one was aluminium cladding, which caused some really horrific disasters. And then the very latest is engineered stone, which is causing horrible illnesses in the people that work with this stuff. So toxic materials are a thing that we've got to always be vigilant about looking out for. Here's another example. You can see this person in the hazmat suit. Yeah, it must be a lot of chemicals in the air that you don't want to breathe. So, and then you really got to ask yourself the question, is there off-gassing through the life of the building that's going to make the occupants sick? And you may have heard of the sick building syndrome, where too many toxic materials in poorly ventilated buildings makes people sick. My favorite non-toxic material is earth. And so the image over here is of the Earth Building Association of Australia, and they've got lots of great information about how to build with earth. All right, so moving on to construction elements. Let's look at the main parts of a typical house. Floors, we'll start with. Basically, the two main options are concrete slab or timber, or as I've already pointed out, I used earth. Yeah, this is a concrete slab. Often there might be under slab insulation, which can, in certain climates, be a good idea to reduce heat flow in the winter. Slab edge insulation is also a relatively new technique to reduce conduction of heat out of that concrete slab. Yeah, concrete, as I already indicated with that little calculation about how much energy goes into making a concrete slab. Oh, I forgot to say that in that calculation it was about 2.5 years of energy use running a typical home. Running that home for 2.5 years would be the amount of energy that went into making the slab. So it's a huge amount of energy, embodied energy in that slab. There are some techniques like using waste products like fly ash to replace some of the cement. The cement is actually the really high embodied energy material. We can use recycled concrete, recycled aggregate and gravel instead of new gravel. And also there's a recent innovation where you can use basalt rebar instead of steel rebar. So there's interesting things going on in the concrete world. These eco-concretes. Back on the concrete slab, putting heating in the slab can be a very energy efficient way of keeping the temperature in the room nice, because the floor is warm and the hot air rises. So that's an interesting idea. You can do that with water pipes or just with a resistive heating element. And of course, the slab can be clad with wood, which I don't love because it tends to override the thermal mass properties of the slab. That thermal mass slab can be great, as I explained earlier, about using that thermal flywheel effect. And I think it's really beautiful when it gets polished. It can just look amazing. Timber floors is the other obvious alternative. You've got to get your insulation right on the underside of these and make sure your termite solution is good. But yeah, timber is a very beautiful and renewable material. We can grow more timber, but of course, looking at those forestry practices is super important. And also with climate change, it's going to get harder and harder here in Australia to grow timber. So look out for that Forestry Stewardship Council logo. Earth floors, as I've mentioned, probably the most sustainable because, earth is just so abundant, very low embodied energy. There's my earth floor once again, and this is the waterproofing linseed oil, another natural material that with low embodied energy, low toxicity, makes it waterproof. All right, so onto walls. Basically, steel versus timber, the jury's out on which is more sustainable. And of course, if you go to the steel website, they'll say they're more sustainable than timber and vice versa. The steel framing is going to be, lightweight compared to the heavier timber, but the embodied energy of the steel is so massive from all the mining and all the high temperature processes that are needed to make steel. So yeah, I think on that one, just sort of don't worry too much about it. Talk to your builder about what they prefer to work with. I've already talked about reverse brick veneer, so I won't go on about that one. But yeah, maybe one little tip is if you use, instead of the 90 mil studs, use 140 mil, then you can get some extra insulation in there. That really applies to any stud wall. Just yeah, it seems like a great idea to me, just getting some extra insulation in there. Here's hempcrete. Hempcrete is great because it's a renewable material that uses very little in the way of fertilizers and pesticides. So yeah, there's lots of advantages to hempcrete, and there's a growing industry in Australia for hempcrete. Straw bale, I've already talked about a fair bit. Just such amazing, the insulation, the walls are so thick, and you know, these quite dense straw bales leads to very good insulation, and typically they get earth rendered, and it's the kind of thing you can actually do yourself. Aircrete, I honestly don't know too much about this, but I'm not loving all the cement content, but they use foaming agents to put a lot of air into it, so that reduces the amount of cement. And then autoclaved aerated concrete. So Hebel is an Australian brand that does this again. It's sort of like aerated concrete. But yeah, as I said, building with earth, it's an ancient technique. This example here, 10,000 years old, you know, ongoing occupancy over 10,000 years. So it's pretty incredible stuff. So rammed earth is a great example of building with earth. There's also mud brick, compressed earth blocks. This is an Australian New South Wales manufacturer, but I'm sure they'd ship to Victoria. And of course, there'd be compressed earth block manufacturers in Victoria as well. My favorite, being yeah, an earthship fanatic, is the using car tires, which of course uses up waste materials, and we fill those tires with earth to make a big eco brick. Similar sort of concept is, instead of filling tires, filling polypropylene bags. So that's super adobe sandbags. So yeah, all sorts of walling options there. And then yeah, what about sheet materials to line your walls or to clad your walls? So WeatherTex is a pretty sustainable one, using waste wood fiber. And yeah, they've done some of that life cycle assessment, global green tag certification to prove how sustainable it is. Durapanel or Durapanel is a straw board material made in Australia, which I think is really terrific and has got a bright future because of its insulative properties and yeah, really low embodied energy, very sustainable. You know, straw is a waste product, as I've already mentioned. It comes with all these finishes. So yeah, you can make it look different easily. Solomit straw board ceilings. Yeah, again, straw, insulative straw. Salvage floorboards, oriented strand board or OSB. This is essentially a waste material, little wood chips that get glued together. A more upmarket version of that is plywood. So again, looking for the Forestry Stewardship Council logo would be important. Steel cladding or lining can be very durable, lasts a long time. But as I've mentioned already, there are some pretty heavy eco impacts from manufacturing steel, but it is recyclable. So many pros and cons, and I'm sorry to say no really clear answers unless you kind of really go down the rabbit hole with paying someone to do a life cycle assessment. plasterboard. We all know about plasterboard, roofing. Sarking membranes and wraps, that's the fabric that goes under your roof cladding. It's an important part of getting a well-sealed roof. Can be important in bushfire zones as well. And the latest, greatest versions of these are vapor permeable, so that water vapor from the house can sort of pass through, condense on the underside of the roof, and then when it drips down, it doesn't go through the sarking. So it's sort of like this one-way street for the water vapor. Important thing to know about roof color is that the solar absorbance, the SA number here, if you get a low number, that gives you a better performing roof, because it's like the darker colors absorb more heat and are therefore less energy efficient. So go for the lighter colors there. Roof framing, similar to the wall framing, kind of conundrum. There's no clear winner with steel versus timber. Yeah, same with the roof cladding materials. I tend to, with my designs, use the lighter weight steel materials. And my strategy is not to do hip and gable roofs where you're having to cut triangles and throw bits away. I love a gable roof where you don't need to do any cutting. Green roofs, slate roofs, here this is more of an ancient material. Green roofs have all sorts of advantages but tend to cost more. But I think they're a great way to get a really good bushfire resilience. So this is one of my designs, little B&B, and you can see the earth-covered roof. It's going to be super easy to defend in a bushfire. Now, windows and glazing. The most important thing here is its orientation. I'm not going to talk too much about that. Basically, facing north is best. Frames are a big deal. So aluminium, the problem with that is it can cause condensation because it gets cold. It's a conductive material. So a well-designed aluminium frame is going to have like some sort of plastic barrier inside the extrusion that's going to stop that heat flow. And perhaps, the ultimate window frame is where you've got aluminium on the outside to reduce maintenance and timber on the inside to reduce that heat conduction and also to look beautiful on the inside. But of course, you pay for it. Plastic framing, again, great for thermal performance because plastic is an insulative material, but there's always a downside. So yeah, like these are the things that you kind of just have to tell your designer what your preferences are. It also comes down to budget. Here, I love working with timber windows, but yeah, you got to maintain those things, which not everyone wants to do. There's the magnetite retrofit I talked about earlier, adding on an extra pane of glass. And you should be aware of the WERS scheme, the energy efficiency window energy rating system. They've got a website that you can basically find out how energy efficient a given window is. There was the question earlier about the insulated glazed units or double glazed units. Pretty sure we do make them in Australia. And here are your key sort of metrics of how a window and window frame system is going to be measured. That U value, remember the inverse of that is the R value, the solar heat gain coefficient, how readily heat caused by sunlight flows through a window, and visible transmittance, how much light actually comes through. So a reminder there about U value and R value. If you can get between 0.2, like that's pretty phenomenal, R5 or U value of 0.2. And note that single glazed is basically R 0.2. So single glazing is is pretty shocking stuff. It's almost like there's just a big hole in your wall. It's not doing a lot. Also, there's all sorts of different glass types. It can be clear or tinted, laminated, toughened for bushfires. You really need to talk to your designer about all these options and what makes sense on a given window. West-facing windows, for example, should probably be tinted to help reduce that afternoon, winter, summer sun from causing big problems. Here's that window energy rating scheme search engine where you can find out what your particular window type is, how it's performing. So yeah, there's some references here on windows. Quick note about the bushfire standard. Your designer, one of the first things you're going to do is find out what your bushfire attack level is, and then your designer understands what types of materials and systems are going to be needed to ensure that that building has the greatest chance of surviving a bushfire. And yeah, unfortunately, the Australian standards are all hidden behind a paywall, but some websites have good summaries of what's inside that standard. Yeah, here's a tip there that the Australian Glass and Window Association have a good summary of that. So this is the end, folks. In conclusion, there is no perfect solution for all sites and all people. It's context specific to climate and budget, etc. So having a conversation with your designer or architect on what types of materials you like and your philosophy on environmentalism is going to help you be happy with the choices you make. Your designer will develop a range of options for you to choose from, and hopefully this presentation has helped you understand how to make some choices that are going to reduce the cost of your home and make it more ecologically friendly. And that last dot point there is, like, I guess my hot tip is that if you can use earth-based thermal mass materials, which has got minimal or no cement, that is a really good thing. And if you can use plant-based insulative materials such as straw bale, hempcrete, or the DuraPanel, I think that's also a really great choice. So there's a few of the associations that I think could be useful in your research on how to build more sustainable. There's a few resources and references there. And that's the end of the slideshow. So thank you for your attention, everyone. Have we got time for more questions?
Thanks so much, Martin. That was absolutely fantastic. There was so much in there, and a lot. Having this feeling listening to you that so much of it makes sense. It's logical, but I'm sure there's plenty of people who don't get an opportunity to think about all that stuff. So thank you so much for putting it all into such a concise presentation for us. And I'm sure there'll be plenty of people watching this who'll probably want to go back and review some of those slides again to get to delve into them in more detail. I'd just like to briefly talk about a couple of things that we have available here in South Gippsland and Bass Coast before getting into the Q&A. Probably the most relevant thing for you is that you may or may not be aware that we have home energy kits available from the local library. So each library in South Gippsland and Bass Coast, all the Miley libraries have home energy kits that have a basic run sheet on how to do a very simple energy assessment of your home. They also have thermal imaging cameras in there, so you can check for hot spots or cool spots where there's gaps in insulation, and they can be just borrowed from the local library for free. So get into that. They also have, we also have induction cooktops available to be borrowed for people who are thinking of getting off gas and want to try induction before you buy. They can also be borrowed from the library. So check those out. Just check out your local Miley library. We've still got about 20 minutes left for questions. So if you have any questions, please type them in the Q&A function and we'll try to get to as many as possible. And a reminder that you can also upvote questions if you like by putting on a thumbs up icon, clicking on the thumbs up icon. But I think we should be right just going through the questions that we have. Please ensure that your questions are entered into the Q&A function and not into the chat because we may not see them there. Okay, so some questions now. We have one here that I think is a comment that is referring to that energy rating idea that you spoke about. So at the moment with the building, houses need to be built up to a particular standard, but without the assessment, they may not actually perform at that standard. And the comment really is around that. The observation that there have been instances where people have paid a lot of money for a 8-star home and have ended up something that performs well below that. And also I had a further to that, a question around a friend of mine who's currently looking at designing a home, particularly a small home, and saying that the challenge that she has, because the place she lives alone, she only wants a small house, the challenge is that it's much harder to reach the 7-star standard with a smaller home. It's much easier with a bigger home. Even though a bigger home is going to use a lot more energy, the performance is on a per square meter basis, and it's a lot harder with a larger, smaller home. Can you comment on that? Is that your knowledge of it?
Yeah. Isn't it silly, really, that you kind of get penalised by building a small home? I guess I can only say that I think things will evolve. The National Construction Code changes every, I think it's, on a cycle of every 3 or 4 years. In future, there's already the goal that future codes will include a lot of the stuff I've been talking about tonight with the embodied energy of materials. That's going to become a thing in the future. But at the moment, it seems to be all about energy efficiency. And all I can say is it's just a bit foolish, really, that smaller homes get penalised. Not sure what to do about it. Sorry, but I'd say go ahead and build your tiny homes. That's a great thing. And probably the thing is you just have to put in that bit extra insulation, or better passive solar design, more windows to the north, less windows to the south, east and west, and you're going to end up with a better result anyway. So I kind of feel like it might be a bit annoying, but you'll end up with a better situation. And the issue of like homes not performing as marketed, as predicted, I gave some clues about how it's quite a difficult thing to measure, just because one person might sort of drive the home differently to another person. So I might be able to get 8-star performance out of the building, whereas someone else might only get 2-star, and that's just because they've left the doors open all day, or so, you know what I mean? So but of course then you just go, well, let's have some standard procedures for how we go and measure the performance of those buildings, and we just sort of take the occupant variable out of the equation, and we just go, all right, well, look, you could just seal the building up potentially, or I don't know, there'd be problems with that as well, because part of the idea of a passive solar home is that you actually have engaged occupants who are opening and closing windows at the right time of day. It's not like the push button house where you set the thermostat and things happen magically. You've actually got people with brains who do things at the right time or not. So this is the problem. Again, not really sure, but just like what I would encourage everyone to do is that these days you can get really nifty temperature and humidity sensors. I've got one that also measures like volatile organic compounds, VOCs, carbon dioxide, carbon monoxide, all sorts of things that are going to be in the air, and you just sort of plug it into your Wi-Fi, and there's an app on your phone that's giving you this performance report every hour or every 5 minutes. You can see what's going on in your home, and I just think kind of everyone should really have one. And then you can sort of show the builder and go, hey man, like, what's going on here? I'm getting this terrible performance. Didn't you put the insulation in the roof? And often they don't. Well, not often, but sometimes they don't.
It does happen. We have got another question here, but a little anecdote for me. I just recently had some electrical work done, and after the electricians had left, I got up into the roof and they just pulled insulation out, moved things around and left it uncovered. So we had these massive holes in our insulation that where they just hadn't put it back, which makes a massive difference to the performance of your home. It's like having a big hole, like having a big chimney, and all the hot air goes out. We've got a question here that's about Trombe walls. Are they worth considering if a sunroom or a greenhouse isn't an option? And if you could just talk a little bit about what they are.
So I pronounce it Trombe. I'm not actually sure.
Sorry. Yep, I could be wrong. Yeah.
But the idea is that you have some north-facing glass, and then on the inside of the glass, not such a big distance away, it might only be let's say 200 or 300 mil away. So one downside is it could potentially be quite an unusable space. But then you've got some thermal mass. So maybe it's a little brick wall or something. Maybe you could have a desk there. And, the idea is that the sun comes through the window, heats up the thermal mass wall, and then will radiate that heat out in the nighttime. So that's what a Trombe wall is. Is it a good idea? I think, to me, it's sort of like, the sun could just be hitting a concrete floor or an earth floor or something. So where the thermal mass goes in the building, there's so many options. The Trombe wall is just one of them. So I think, that could be a beautiful little design feature for sure. But I don't think, I think there's other ways that you could probably use the space more efficiently. Because that's a big deal in a building as well. Is how do you, if we're trying to minimize the space, how do we use that efficiently? But talk to your designer about Trombe wall if you really love that idea. I think it could be a really great thing.
Yeah, I first one I ever saw was actually up in the Himalayas, and it was similar to how you described, black painted, and they had vents at the top and the bottom, and obviously it created that circulation. And in a climate where it is very dry, very often clear, cold but clear, they get a lot of sun, and but the air temperature is pretty cold. It probably makes sense. But you're right. There's other things you could be using that space for.
Yeah.
Have we got any more questions? Please pop them into the Q&A. I've just got one for you, Martin, around plasterboard and your thoughts on the sustainability and life cycle of plasterboard. I have heard from a builder that it's a natural material. It can just go back into the earth at the end of its life, but I'm sure there's other stuff in there that may not be so natural.
Yeah, I think the problem is that it doesn't. There's a lot of things that are technically possible. But does it happen? There's an argument that we just need to improve our recycling systems. But I think, the plasterboard's basically got a skin of paper or cardboard on it. And so separating that away from the plaster, I don't think is the easiest thing in the world. And so I think what generally happens is it just ends up in landfill. Don't quote me on that, but I think, a fair amount of plasterboard goes to landfill, not much gets recycled. So yes, technically it probably can be, but I don't think it does. And I'd say that the plasterboard is reasonably high in embodied energy. Making the plaster would involve some process energy. But look, the other thing to judge things by is that it's relatively cheap. And, energy is money kind of thing. So if something is relatively cheap, then perhaps that's an indication that there's not as much embodied energy as you might think. It's probably okay.
Yep. Good point. One other question I have is around hempcrete, and I understand that the hempcrete itself is a very sustainable product, but often where I've seen hempcrete, it's often with fairly large steel frames holding up everything else. I guess that's always a balance with a material like that, or is there a way to do hempcrete where you're using high embodied energy steel for framing?
Let me just go back one step. I just remembered something. Magnesium oxide board is an alternative to plasterboard, more sustainable.
Okay.
So look up magnesium oxide board or MGO board. But yeah, your question about the hempcrete and the framing. I've also seen plenty of hempcrete buildings with timber framing. So I think, yeah, the steel versus timber thing is a interesting question. Yeah, so hempcrete and straw bale buildings often have what they call post and beam construction, where instead of like lots of little wall studs at 450 or 600 centers, you've just got like big posts every 3 meters or something. So yeah, post and beam versus stud walls is another sort of life cycle assessment question where you'd have to actually calculate the mass of those materials in those two different wall systems to really find out what the predicted answer to that is. So yeah, the other thing about hempcrete is it does use a lime binder. So lime is a little bit like cement in the sense that it's got quite a bit of embodied energy. So that's if we're doing a pros and cons of hempcrete versus straw bale. Straw bale, there's no lime binder that's all mixed in with it. It's just straw. Whereas hempcrete's all glued together with lime. So
Yep.
yeah, that lime has embodied energy and doesn't get talked about a lot.
Fantastic. Great point. Okay, thanks very much, Martin. Thanks, everyone. That's all the questions we have for tonight. Thanks, everyone, for your time. I hope the event was informative and has helped you answer some of your questions you may have had about how to pick the right sustainable building material for your renovation or for your build. Can I extend a special thank you to our expert presenter tonight, Dr. Martin Freeney, for lending us his expertise and experience for the evening. And also thanks to Doug from Renew for his behind-the-scenes support. Before we close the event tonight, I'd like to remind you that the next webinar in our Sustainable Living series is around water and greening and will be at the same time next week on Wednesday, the 25th of September from 6 to 7:30 p.m. You can register for that webinar and others in our series on the website, on the CAP website, which there's a link to in the chat there. And a final reminder too that this webinar has been recorded and will be posted in the next fortnight on our website, and you'll be able to find recordings of all our other webinars there. That's all for tonight. Thank you very much again for your attendance, and I hope to see you all again next week. And thanks again to Martin. Bye for now.